Welcome back students. We are discussing about ray optics and optical instruments, where we have discussed about reflection and refraction of light, spherical mirrors, sign convention, relation between F and R, mirror formula, magnification and refractive index. We have already discussed in our previous videos. If you have not yet subscribed to my channel, you can subscribe the channel and you can go to our playlist and check them out. Today's video we are going to discuss about total internal reflection. So let us start. Before going to discuss about total internal reflection, let us understand critical angle. So in order to understand critical angle, we have an arrangement here. So you can see here, this is the outside area is rarer medium and this blue color area is the denser medium. So as we know, when light goes from rarer medium to denser medium, what happens? It bends towards the normal. So it is bending towards the normal. Now if we flip the scenario in this manner, what will happen? You can see. Then this is the denser medium now and this is the rarer medium. So when light goes from denser medium to rarer medium, the scenario will be opposite. What will happen? When light goes from denser medium to rarer medium, the light bends away from the normal. So this is the case where when light goes from denser medium to rarer medium, it bends away from the normal. Now you can see here this yellow part of this incident light and there is another part, that is the light blue part. There are two parts of the incident light. Why there are two parts? We can say that this part is reflected back in the denser medium and this part is refracted back or refracted in the rarer medium. So there are two parts. So we used to say this part which is going back in the same medium is partially reflected ray and this is partially refracted ray. Okay. So now what happens here, if I move the position of the stars from position 1 to position 2 somewhere here, then what will happen? This refracted ray will bend more away from the normal. So it will go like this, position 2. So if I move again this from position 2 to position 3 somewhere here, then what will happen? It will again move. Now we can see that it is the light ray which is refracted because of the movement of the stars. Now at this position 3, the refracted ray is just tracing over the surface of the denser medium, or you can say tracing over the interface of two medium. So here we can see this is the refracted ray. So at this point we can say that the incident ray in the denser medium, this is the incident ray in the denser medium making an angle with the normal. So this is the normal and that is the angle I, this is incident angle, and for this incident angle we can see that the refracted angle now become, what is the refracted angle now become? This is the refracted angle or angle of refraction. This is nothing but R and it has become, now we can see this part, okay, it has become 90 degree. So at this position, if the refracted angle become 90 degree for the incident angle I, then we say that angle I is called, or we say that angle I is critical angle. So we can write IC. So if you want to define critical angles, then we have to write that when light passes from denser medium to rarer medium. So this is a very important point to remember, that light must pass from denser medium to rarer medium in order to get a critical angle. So when light passes from denser medium to rarer medium, then the angle of incidence in denser medium, so you can see the angle of incidence is this, angle of incidence in denser medium. So this is the denser medium, for which the angle of refraction in rarer medium is 90 degree. So for which the angle of refraction for the rarer medium is 90 degree. So you can see here, this is the rarer medium where the angle is 90 degree, is called as critical angle. So this angle, this incident angle for which the angle of refraction in rarer medium is 90 degree, then we call this incident angle as critical angle. We can have a relation with the critical angle from Snell's law, as we can write that from Snell's law we got, if you can remember Snell's law. So what we have got, we can write from Snell's law that N2 is the effective index of medium 2 into sine I C. Since we have considered this as medium 2, denser medium as medium 2 and rarer medium as medium 1. So we can write the refractive index of medium 2 into the sine of the angle of incidence, that is sine IC, and that is equal to, from Snell's law we are writing this, n1 into sine r. Sine r is nothing, it is 90 degree. So what we can write here, n1 into sine 90. Sine 90 means sine 90 degree. So sine 90 degree means 1. So it will be n1, it is n2 sine IC. So we can write here what will be n2 by n1. n2 is there, n1 will be there. n2 by n1 will be nothing but 1 by sine IC. So if we write here, n21 is nothing, it is the refractive index of 2 with respect to 1. So that is equal to 1 by sine IC. So here you can see from the critical angle we can also find the refractive index of the medium. So here we can see the refractive index of medium 2, that is the denser medium, is equal to reciprocal of the sine of the angle IC, that is the sine of the critical angle. So if we know the critical angle, then we can find the refractive index of the medium, or if we know the refractive index, then we can easily find the critical angle of the medium. So that is the concept of critical angle. Now let us understand total internal reflection. Now what happens, here we have considered the position 3, from 1, 2 and 3 we have considered 3 positions. Now if we go beyond 3, then what will happen? If we go beyond the position of 3, suppose the position 4 is here now, then what will happen? We see that the light is now going inside the same medium. So the angle of refraction is now greater than 90 degree. We can see here this angle is 90 degree. Now there is additional angle here. So overall angle become greater than 90 degree. So when it is greater than 90 degree, that means we can say that the angle of incidence is now also greater than the critical angle. Angle of incidence is greater than critical angle. So when it happens, then what will happen? Instead of refracting in the rarer medium, it will reflect back in the denser medium. The totally it will reflect. There is no partial part which goes to the rarer medium after refraction. There will be no partial part. So total light, all the light will get reflected inside the denser medium. So this phenomenon is called total internal reflection. So we have seen in our previous concept of critical angle that light is at the interface, it can divide into 2 parts. One is the reflected part, another is the refracted part. This is the refracted part and this is the reflected part. But at this point, when the angle of incidence is greater than the critical angle, what happens? There will be no 2 part of partially reflection and refraction. So only 1 part will remain. So that is why all the light will be there in the reflected ray. That is why we called it as total internal reflection. So you can write total internal reflection as when a ray of light traveling from denser medium to rarer medium. So it is important, okay, again it is important that light must travel from denser medium to rarer medium, is incident at the interface of 2 media. So this is the interface of 2 media. This part is called interface of 2 media. This color, blue color, is the denser medium and this is the outside black area is the rarer medium. So interface of the 2 media at an angle greater than the critical angle. So this angle is now greater than critical angle. This angle is greater than, this is IC, but it is greater than critical angle. So greater than the critical angle, then the ray is totally reflected back. So we can see the ray is totally reflected back in the same medium. So this medium and in the same medium, the incident ray in the denser medium, the reflected ray also in the denser medium, and this phenomenon is called total internal reflection. So that is why it is called total internal reflection. So there are necessary conditions for total internal reflection. So what are the conditions? We can see here. The ray of incident on the interface should travel from denser medium. So this ray must travel from denser medium. We cannot draw or we cannot get a critical angle or total internal reflection if light is coming from rarer medium to denser medium. It must be coming from denser medium to rarer medium. Then we may get the condition or phenomenon of critical angle and total internal reflection. And the second point is the angle of incidence should be greater than, so the angle of incidence should be greater than the critical angle for the two media. So the critical angle for two media, if IC, then the angle of incidence must be greater than IC. Okay, why here it is said for two media? Because different media have different critical angle. Suppose this is water and this is air, so they must have critical angle which is different from a critical angle of two media. Suppose this is oil and this is water, so their critical angle will be different. So for different media there will be different critical angle. So that is why the condition is said in this manner, in this way. So hope you have understood the concept of critical angle as well as the total internal reflection. And in our upcoming videos I am going to show you different examples and different applications of total internal reflection, critical angle, and so on. And in our next video I am going to discuss about reflection at spherical mirrors, spherical surface and lenses. So we have already discussed about mirrors, I think spherical mirrors. So in our next video I am going to discuss about reflection at spherical surfaces and by lenses. So this is very important for the point of examination purpose, also for the point of concept. Okay, then we will discuss about thin lens formula, which is very important formula. Then we will discuss about combination of thin lenses, then prism and rainbow formation, how rainbow forms. We will discuss all these things. Then we will also discuss about scattering of light. Then we will discuss about some optical instruments like telescope, compound microscope. And after all these videos, at the last I am going to summarize all the concepts of the chapter for quick revision, and I will also give you some examples, some problems, and all the notes of our videos. So thank you for watching, and don't forget to subscribe if you are new to my channel, and if you are not new to my channel you can share this with your friends so that they will also get benefited from these videos.